Imagine a multi-million-dollar road construction project coming to a catastrophic halt because the asphalt in a transport truck suddenly ignited. It sounds like an absolute nightmare, right? But here is the reality. Without one crucial laboratory test, working with hot asphalt is a literal ticking time bomb. Today we are talking about the unseen hero of road construction safety, asphalt flashpoint testing. Welcome back to the channel. If you are a civil engineer, a paving contractor, or a materials testing technician, you know that asphalt is the lifeblood of modern infrastructure. But to make that asphalt workable so it can be poured and compacted, it has to be heated to extreme temperatures, often well over 300 degrees Fahrenheit. Here is the problem. As asphalt heats up, it releases volatile vapors. If those vapors mix with the oxygen in the air and encounter an ignition source, like a spark from machinery, a static discharge, or a hot engine manifold, they can combust. This is where flashpoint testing comes in. The flashpoint is the lowest temperature at which a liquid gives off enough vapor to form an ignitable mixture in the air near the surface of the liquid. It is the exact temperature threshold where a material goes from being safe to handle to becoming a severe fire hazard. Knowing this exact temperature isn't just about following the rules. It is a vital step in ensuring road safety, protecting the lives of the paving crew, and preventing catastrophic equipment fires. Today we are going to dive deep into the specific equipment that makes this vital safety check possible. We will be looking at the Cleveland Flashpoint Tester, the TAG Open Cup Flash Tester, and the essential components that keep these machines accurate, the flash cup and the heater coil. We will explain exactly what each machine does, how it works, and why you need them in your testing arsenal. Let's get to work. Let's start with the heavy hitter in the asphalt testing world, the Cleveland Flashpoint Tester. If you are dealing with asphalt cement, heavy oils, or viscous petroleum products that have a flash point above 79 degrees Celsius or 175 degrees Fahrenheit, this is your go-to machine. The Cleveland Flashpoint Tester operates on what we call an open cup principle, conforming strictly to the ASTM D92 standard test method. Here is why this machine is so incredibly important. When you are testing pure asphalt binder, you are dealing with a material that requires intense heat to become fluid. The Cleveland Tester is designed specifically to safely handle and test these high heat materials. So how does this machine actually work? It is a fascinating process of precise thermal control. First, the asphalt sample is heated until it becomes liquid enough to pour into the heavy brass test cup. You fill the cup exactly to the designated fill line, no more, no less, because the surface area exposed to the air is critical for an accurate test. A specialized thermometer is suspended directly into the center of the asphalt sample to monitor the temperature in real time. Then the heating begins. The operator turns on the heater, raising the temperature of the asphalt at a very specific controlled rate. As the temperature climbs, the asphalt starts emitting vapors. Once the sample approaches its expected flash point, the operator uses the test flame applicator. This is a small wand that passes a tiny, carefully regulated flame directly over the center of the cup, just slightly above the surface of the asphalt. The operator sweeps this flame across the cup at regular temperature intervals. They are watching for one specific event, a sudden, brief flash of blue fire across the surface of the liquid. The exact temperature at which that flash occurs is recorded as the flash point. If you keep heating the sample and applying the flame until the asphalt actually catches fire and burns for at least 5 seconds, you have found the fire point. The Cleveland Open Cup Tester is brilliant because it gives you both of these critical safety metrics in one standardized test, telling paving crews exactly how hot they can safely heat their specific batch of asphalt. Now you might be wondering, if the Cleveland Tester is so great, why do we need anything else? Well, the world of paving doesn't just use pure heavy asphalt cement. We also use cutback asphalts. Cutback asphalt is essentially regular asphalt cement that has been dissolved in a petroleum solvent, like naphtha or kerosene. This is done to make the asphalt liquid at lower temperatures, which is incredibly useful for tack coats, surface treatments, or cold weather patching. However, because it contains highly volatile solvents, cutback asphalt has a much lower flash point than pure asphalt cement. This makes it significantly more dangerous to handle if you don't know its exact properties. This is exactly where the TAG Open Cup Flash Tester comes into play. Governed by the ASTM D3143 standard, the TAG Open Cup is designed specifically for testing these low flash point cutback asphalts and other highly volatile liquids. The operation of the tag tester is distinct from the Cleveland. Instead of a heavy brass cup sitting directly on a high-powered heating coil, the tag tester uses a delicate glass test cup. More importantly, this glass cup sits inside a liquid bath, usually a water bath or an ethylene glycol bath, depending on the required temperature range. Why a liquid bath? Because when you are dealing with highly volatile solvents, you need an incredibly gentle, slow, and uniform heating process to prevent the sample from boiling or flashing prematurely. The liquid bath ensures that the heat transfers evenly to the sample inside the glass cup. Just like the Cleveland tester, the sample is slowly heated, and a test flame is repeatedly swept across the surface. Because cutback asphalts give off dangerous vapors at much lower temperatures, the tag open cup tester acts as the ultimate safeguard. It tells transportation crews and contractors exactly how volatile their cutback mix is, ensuring they don't accidentally ignite the solvents during transit or application. It is a completely different machine for a completely different class of asphalt, but it is equally vital for road safety. Let's zoom in and talk about the individual components that make these tests reliable. Up first is the flash cup for the Cleveland flash tester. To the untrained eye, this might just look like a heavy little brass bowl with a handle. But in the world of materials testing, this cup is a precision-engineered instrument. It is forged from solid brass for a very specific reason: thermal conductivity. Brass distributes heat incredibly evenly and consistently. If the cup were made of a cheaper metal that developed hot spots, the asphalt sample would heat unevenly, releasing vapors erratically and completely ruining the accuracy of the flashpoint test. Furthermore, the geometry of this cup is strictly regulated by ASTM standards. It has a precisely machined interior diameter and a specific depth. Inside the cup, there is an exact, non-negotiable fill mark. If a laboratory technician overfills the cup by even a fraction of an inch, the surface of the asphalt is too close to the test flame, resulting in an artificially low flash point. If it's underfilled, the vapor concentration changes, leading to an artificially high flash point. Over time, these cups endure extreme abuse. They are subjected to intense heat, covered in sticky asphalt, scraped clean with harsh solvents, and sometimes the asphalt inside them is intentionally set on fire to find the fire point. Because of this wear and tear, having a pristine, perfectly dimensioned replacement flash cup for your Cleveland tester isn't just a good idea. It is a strict laboratory requirement to maintain your testing accreditation and ensure the numbers you are giving to the paving crews are absolutely flawless. The final piece of the puzzle is the engine that drives the entire Cleveland testing process: the heater coil. Flashpoint testing is completely dependent on the rate of temperature increase. According to ASTM D92, once you get within a certain range of the expected flashpoint, the temperature of the asphalt sample must rise at a very strict rate of 5 degrees to 6 degrees Celsius or 9 to 11 degrees Fahrenheit per minute. If your heater coil is old, damaged, or inconsistent, you simply cannot maintain this precise heating rate. If the asphalt heats up too fast, you will blast right past the flash point before the flame sweeps across the cup, giving you a falsely high and dangerous reading. If it heats too slowly, the lighter volatile compounds might evaporate away before the flash point is reached, again, giving you an inaccurate result. The heater coil for the Cleveland flash tester is an exposed high wattage element designed specifically to deliver raw, yet highly controllable power. Because it is exposed to the extreme heat of the test and sometimes subjected to accidental spills of hot asphalt, the element will eventually degrade. It might develop cold spots or burn out entirely. Having a high-quality, perfectly calibrated replacement heater coil ensures that your temperature ramp-up remains perfectly linear and entirely compliant with ASTM specifications. It is the heart of the machine, and without a reliable coil, your flashpoint data is essentially just guesswork. Ultimately, materials testing is about human lives. Paving crews and transport drivers rely on precise data from equipment like the Cleveland and tag open cup testers to stay safe on the job. By investing in reliable lab gear, you are actively ensuring road safety before a single drop of asphalt even touches the ground. For trusted lab equipment, including the Cleveland and tag open cup testers and their replacement parts, head directly to Certified MTP. You can find the links and specs in the description below. If you found this breakdown helpful, please subscribe and like this video. Thanks for watching and stay safe out there.